So today we're going to talk about two things, mostly a little bit about climate change and then a lot of bit about this trip I took up to Greenland with NASA, and I'll show you some details. So I think I'm just going to get started, and I'm looking to see if people have questions and whatnot. You can just type it. So let's go, shall we? As I said, I work at NASA, and NASA has 10 different centers. And one of them is Jet Propulsion Laboratory in Pasadena. And I don't know how big your screen is, but over there on the left, what you can see is the laboratory. And it's huge. It's 3 times the size of Disneyland. So that just kind of gives you some scale of where I work. And on the right-hand side of this photo, you can see mission control. And mission control is where people sit at computers and they send messages up to the satellites in space, and then they also receive data from the satellites back down to Earth. So that's the picture on the right. So that's who I am and where I work. And then this is one of the 2 museums at Jet Propulsion Laboratory, and you can see a group of 3rd graders is at the museum, and this is a photo of me talking to them. And I remember this day very well because these kids were really, really well behaved. And I was like, well, a field trip should be fun as well as educational. So I was all like, who likes Justin Bieber? And they were all making all this noise. And then I said, who wants to be a scientist when you grow up? And it was really, really quiet. And then finally one kid, these guys are 3rd graders, they're 9 and 10 years old. One kid says to me, I'm not smart enough to be a scientist. And so I kind of, puffed myself up as though I was going to beat up the person who made him feel bad about his intelligence. And I said, who told you that? And he said, I thought it in my own head. And a whole lot of kids in the class raised their hand and said they also thought in their own head that they're not smart enough. And it's my mission here today to tell you, first of all, that you are smart enough. And there's this idea, I think, that people have in their head that, intelligence, you either have it or you don't. And it's just basically not true. And the other thing that is even more true than that, that's more important than some like random IQ thing, is how much effort and how much work and how much determination you have. So all those 3 things, effort, work, and determination, will outplay IQ points every day, every single time. So my message to you at the beginning and then at the end again is keep working hard and keep trying. It's more important than anything else. Okay? So pretty much when people say NASA, in fact, this happens to me all the time. It happened to me last week. People are like, are you an astronaut? You work at NASA. Well, NASA has about 6 astronauts, but NASA also has 20,000 employees. And so our jobs range from studying the solar system to studying other planets outside the solar system to sending robots to Mars. But we also study Earth, and as you can see, that's a photograph of a rocket being launched, and that's an oceanography rocket that's being launched. I was actually there for that launch. And NASA looks down on our home planet. Now, a lot of people, maybe you probably know that, and if you want, you could type in the chat if you already knew that NASA studies our home planet. And oftentimes I give a lot of talks, so I ask people this question, and about half or maybe more than half of the people I talk to know that NASA studies planet Earth. But then I say, how many satellites does NASA have studying Earth? And the answer, usually people guess. Should I give you a chance to guess? Let me give you a chance to guess then. So I see that there's 9 classrooms. Okay, so somebody's guessing 100. So how many NASA satellites? Somebody's guessing 12. I'm just going to give you a minute or so to type in. 30,000, someone's saying. Okay, so these are all normal answers. You guys are right in the range of a normal answer. 20, 500. Okay, good, good, good. So normally the range is somewhere between 2 to like thousands is the normal guess that I get from people. And here's the answer. So the answer is right around 20. And so yeah, public high school A, guessed it right. Yay for you guys, you get a big star. Or maybe you already knew that you didn't have to guess. So we have about 20 Earth-orbiting satellites, and you can see in this photo, each one of those satellites is basically turned to face our planet Earth, so it's taking a selfie. So you can wave up to the satellite right now, and it's taking your selfie. Actually, that's not true. But all those are taking a selfie of us. And so what that tells me when people have these wild guesses is that we need to do a better job of explaining what a NASA satellite is. So I know people oftentimes guess in the thousands, and there are thousands of satellites, but those are like telecommunication satellites and like GPS from your phone and satellite TV, those types of satellites, and there are thousands of those. But I'm talking about NASA satellites, and the NASA satellite, the ones that you see in that graphic right there, are one-of-a-kind, handmade science experiments. So you can't just go buy it off the shelf and launch it. It's handmade in a lab. And they're ours, they're yours and mine, and they belong to all of us. And when I say they're experimental, it's like doing a science experiment, except it's a science experiment that's a robot that's shot into space. And we have about 20 of them, and each one looks at something different. So maybe they're going to look at the infrared, or maybe they're going to look at how high the mountains are, or maybe they're going to look at Earth's gravity field, or Earth's atmosphere carbon dioxide content, or Earth's water vapor content, this sort of thing. And so there's 20 different ones. And then I'm still kind of just giving you a little bit of background about myself. This is the website that I work on. It's NASA's Global Climate Change website, and I actually went to Greenland. The last half of this talk, I'm going to talk to you about Greenland, and that's a photo that I took. It's on our main page. And just in case I don't answer every single one of all your questions and you don't learn every single aspect of climate change in an hour, you can go to that website, and there's a main website. There's also a Climate Kids aspect to the website. So there's all kinds of activities you can do and things you can click on. And just a little bit about me. I think this website demonstrates that some people who have a degree in science get a PhD and they're a research scientist. But you can still work in science even if you don't have a PhD and do research. And science involves writing, graphic design, art, photography, video making, all these types of things. And one of the things I've noticed in my life is that the people who have these more than one skill set. So let's say you like science, but you also like writing, or you like science, but you also like graphic design, or you like photography and art, or map making. Those people tend to not only have the best jobs, and when I say a best job, they have the most fun, and they make the most money, so that makes a good job, fun and money, and also you've got a lot of jobs to choose from, so you can have your pick of getting hired. So I just recommend to kind of get good at one or two skill sets. And if you're really good at photography, you can have a job in science. If you're really good at art and graphic design, you can have a job in science. So don't just think that you're only limited. Okay, moving on. So this is two things here. This is a kind of example of the data that those 20 satellites collect, but it's also an example of, you can see art and graphic design. So over here on let's look at the right first. So the right one is obviously, it's a visual image taken by satellite. It's a montage, and you can see planet Earth, right? So it's obviously a selfie taken by a NASA satellite of what Earth looks like. Now the middle shows you Earth's carbon dioxide concentration, and the red is more, the yellow is medium, blue is slightly less. And over there on the left, you can see that that's a picture of the Pacific Ocean. And you can see, I don't know if you can see my mouse going over it, but you can kind of tell we're on the left globe, and you can see North America is that gray, dark continent on the upper right-hand corner of the globe. And then mostly that green and white and blue color is the Pacific Ocean. And that shows you that satellites also measure the temperature of the ocean. So the red and the white color are warmer, and the bluish purple color are cooler, and the green color is like average temperature of the ocean. So we can actually measure the temperature of the ocean from space, and imagine how difficult that would be if you were trying to do it by boat, right? So a boat zigzagging across the Pacific Ocean would take like years to get that amount of data. But a satellite can collect that amount of data in between 3 and 7 days. So you're constantly getting an entire picture of the ocean from space. So that's why it's important to have these satellites. I just have to show you something. Hold on. My dog is here. I know I told you I work at NASA, but today I'm working at home. Come here. My puppy came to say hi to you guys. Here's the puppy. Want to say hi to all the students? So I just got distracted for a second because he came to say hi and I was petting him. Yes, say hello. He's trying to lick him. Look at his face. Look right there, Benny. His name's Benny and he's wearing a little sweatshirt because it's a little cool today. Okay. Anyway. Oh, hi. Honey, they're saying hi to you. Okay, so that's just a sampling of some of the kind of data that we are able to get from the satellites. And I think it's one of the good things to understand about science when somebody tells you something like, I'm going to go on and I'm going to tell you a bunch of facts, right, and give you some evidence. But a good question to ask is, well, where did she get this evidence? And as you continue throughout your school, into your high school, into adulthood, it's always a good question to ask is, where is the evidence coming? And I'm telling you, this evidence is coming from NASA satellite data. And here's some of the things that we find. So one thing that we found is we found an increase in carbon dioxide concentration. And you can see it kind of, here's the historical record, and then here's where carbon dioxide is now, all the way up on the right. I can't tell if you can see my mouse, so maybe I'll just describe it verbally. You can see that orange line is the carbon dioxide. No mouse. Okay. So you can see the orange line going up and down and up and down and up and down, and that's just the historical record of carbon dioxide in Earth's atmosphere. And then if you see all the way on the right where it says current level, how high the carbon dioxide concentration is. So the way carbon dioxide gets into Earth's atmosphere is people burn fossil fuels. A fossil fuel, F-U-E-L. So a fossil fuel is coal, oil, or natural gas. And we burn these either in vehicles like planes and cars and such like that, or we burn them by using electricity at a power plant. And when we burn these fossil fuels, it puts carbon dioxide into our atmosphere. And you can see by this graph that we've gone way past this normal cycle. See, there's a normal natural cycle, but we are extremely outside of that natural cycle, and that's because, of humans. So I'm going to show you this next. Okay, here we go. So this is what happens to Earth's temperature when we add all this carbon dioxide. Now, carbon dioxide it traps heat, and you can see here's the temperature from 1880, and if you go all the way up to currently, you can see, well, this is just as of last year, the temperature's really, really gone up. And then I wanted to also show you this. So this just shows you can you see it's the whole planet? So here's North America, South America, Africa, Australia, India, Russia, and China over here. And blue is cool, and yellow and red is warm. And here's the dates. So what I'm going to do is I'm just going to slowly slide this up, but I want to get it kind of more in the middle, and then slowly slide it up. Again, this is my website, so you can go on here too at your leisure. It's climate change, climate.nasa.gov. So it starts in the late 1800s, and you can kind of see there's a lot of blue. It's nice and regular temperature on planet Earth. And then here it's like, 1960s. And then it's kind of starting to get a little warmer. I just want you to be able to see the whole thing. And getting warmer and getting warmer. And all of a sudden it gets pretty warm. Just seeing the picture of scientists right now, somebody's saying. Oh, maybe I just pushed go. Maybe that's... So you're not seeing what I'm seeing, huh? Scroll down and saw it. Oh, okay. So maybe I could just go. I wonder if I could go full screen. Is that pretty obvious? I'm going to do it again for everybody. Did you see that? So I need to hear that you guys see that. I'm going to do it one more time. So I'm going kind of 100 years of temperature records. Oh, you don't see it. Okay, so how do we can see the page, but you have to scroll down the graph. And are you seeing me? Yes, Tom says yes. Okay, good. Now, right now I have on the screen this picture of planet Earth, right? It's a map, and you can see a lot of yellow and orange and a lot of red. Does everybody see that right now? Yes, awesome. Okay, and where do you see the most red is you see it in the north, right, near the Arctic and near like Canada, Russia, up at the top. And this is data from up to 2015. So we're just adding the data from 2016 now. So I'm just going to go really quickly back. You see here's 100 years ago, 50 years ago, 20 years ago. I know most of you were probably born around 2005 or so. It starts to get warm, and then now it's like really, really super duper warm. So that's what happens. It didn't play here. That's what happens when we added carbon dioxide to Earth's atmosphere. We increased the global temperature. And you can see here, this is just the 10 hottest years ever recorded. Okay? So if you look, the hottest year ever recorded was just this past year, 2016. The second hottest year, 2015. The third hottest year, 2014. So you can see how it's like every year is hotter than the next. But if you look at the 10 hottest years, all of them have happened since 1998, the 10 hottest years ever recorded. So we've added this carbon dioxide to Earth's atmosphere. It traps the heat, and Earth is getting warmer. So what happens when Earth gets warmer is you see ice start to melt. And you can see this photo here on the left shows that they're the same exact photo, so taken at the same exact location in July. Both of them were taken in July. And about 100 years ago, you can see this giant amount of ice there that is all melted, and now you have a lake. I mean, the lake is really, really pretty. But what happens when you melt the ice is that you get sea level rise. And we've had considerable amount of sea level rise on planet Earth. And you can see this is just, remember I showed you that launch of the oceanography satellite at the beginning of this slide deck. And you can see here's the data, right? So on the y-axis is the amount of sea level rise, and on the x-axis is the year. So in, just over, 20-something years of collecting data, sea level has risen considerably, and it's even kind of rising faster and faster now. So people who live around a coastline, that affects us. And even for people who don't live around a coastline, we're still affected by floods and storms that happen on a coastline because they're our neighbors. I mean, even sometimes I look at satellite photos of places that I've never been to that are very far away from me, and I still feel connected because even though it may be all the way on the other side of the Earth, it's still my home. I still live on planet Earth, as do you. And even everybody on this conference call right now, we're not in the same location, but we're all in a way on planet Earth, and it's all of our home. So when sea level, the ocean, you probably already know, 70% of the world is covered by an ocean. And if we're raising the sea level all the way around the world, all over the ocean at the same time, of course, it's going to have a huge impact, not only on my life, but on all of you, because you're younger than me, so you're even going to have more of an impact than I will. So now I put up this really depressing photo for you to just take a moment, and I'm not really trying to bum you out. Well, I am. I'm trying to bum you out just a little bit so that I can kind of give you some hope and make you look forward to something. And I know you might have heard, or you probably have heard, that a lot of people are saying stuff like, oh, no, it's not people, which is why I put this up. The bird is saying, hey, it wasn't me who made all this pollution, and you can see the different plastic pollution around there. And the truth is that if just one person throws a piece of plastic, a water bottle, a cigarette butt into the ocean's pretty big, it can handle it. But the truth is that we have 7 billion people using a lot of things, and that we've kind of started, we have started to overcome the system by the amount of waste products that we put into our environment. And we can see plastic pollution. If just one person threw a piece of plastic, probably wouldn't even notice it. But there's so much plastic pollution, it's starting to wash up on the beaches. And the same thing is happening with carbon dioxide. If just one car or one little factory put a little bit of carbon dioxide into Earth's atmosphere, the Earth would be fine. But the point is, it's the quantity, and you can think of how many cars there are just in your life when you imagine wherever you are driving, or how many planes, or just how many people on this Earth are having power plants to run all their electricity. It's starting to overwhelm the system, and we can see all the way from space, the amount of carbon pollution that we're putting in our atmosphere. And that's the truth. And so it is you. And I'm going back to this to just show you that we've got these 20 Earth orbiting satellites. But in addition, now moving on to the second part of the talk, in addition to the Earth orbiting satellites, NASA also has a series of airplanes that do science. So we do what's called remote sensing. So we can remote sense from space, but we can also do remote sensing from a plane. And the nice thing about a NASA airplane is that when you send up a satellite, there's no people on, well, I shouldn't say that. One of these, somewhere on here is the International Space Station. Where is it? Somewhere, oh, here. The International Space Station is, you can see it, it's where it says Rapid Scat and CATS. Those are two instruments on the International Space Station. So if you're looking at the top right, you see Jason 3, Discover, SMAP, and then Rapid Scat and CATS. That is the International Space Station. So yes, there are people on those. But for the vast majority of these instruments, they're robots that are sending messages back and forth to controllers down on Earth, right? But the nice thing about being on a NASA airplane is that people are on these NASA airplanes. So I'm going to show you what it's like to be on a NASA airplane now, because I've been on some. So that's a picture of me. And what a NASA airplane is just a regular airplane, like a commercial jet. This is a small one. And instead of like seats and stuff inside, a lot of the seats have been removed and there are science instruments inside the plane. And I'm going to show you some photos of inside these planes in a couple of different planes. And I can tell you it's really fun to do science in an airplane. I'll promise you that. So if you look, there I am, kind of getting ready to walk up the stairs. But see that big white kind of tube-looking thing that's mounted on the underbelly of the plane? That's a science instrument. That's actually a radar. So you can measure all sorts of things with that radar instrument. So there's an example, you can mount an instrument on the bottom of a plane. That's one thing you can do with a science plane. And this is just a close-up of the outside of the plane. And it's looking at, those are windows, or you can see the tail of the plane and the wing kind of in the background, and that little sign, it says NASA Earth Science. But all those things poking out the windows of the plane have been removed, and all of those are science instruments. Just poking out the window, taking air samples. So wherever you go, if you fly across a forest, you can take an air sample of the forest and you can see the pine that the forest gives off, or you can see some of the how much carbon dioxide is being taken up by the trees, all kinds of examples of that. Or if you fly over a city, you can measure some of the pollutants. You can go from a high altitude to a medium altitude to a low altitude and compare the different air samples. So those are all kinds of instruments sticking out of the plane. Here's another plane. This is the plane that I flew into Greenland. And here's me up in Greenland with a different plane. These are all the outside of the plane. I promise you I'll show you the inside of the plane in a second. Here's the inside of the plane. So as you can see, there are some places to sit, but most of the chairs have been taken out of the plane and there's science instruments. So it's just like what you would imagine a scientific lab to be, except instead of in a building, it's inside of a plane. And one of the interesting things about being in a science plane, like for me, I've been on a commercial airplane and it's kind of boring. You're strapped into your seat. You have to stay in your seat. You're squished in there. But when you're on a science plane, everybody's wearing a headset, and you can see I've got a headset on. So everybody's talking to each other, which means the pilots are talking to the engineers, which are talking to the instrument operators, and they're also talking to the scientists. And they're not just flying from airport to airport. Sometimes you'll have to fly over a place and do like a lawnmower pattern to actually collect the data and do the science. And there's other different types of patterns. So if you want to fly from altitude and down low, the other thing about flying in these planes, it really helps to not get motion sick. So I don't get motion sick. And pretty much you take off and then they say over the headset, get out of your seat and start working. So everybody's just moving around the plane and doing all kinds of work. And you can hear, the pilot is saying, did you collect the sample? And the engineer will ask the scientist, and the scientist will either say, yes, we got really good data, or no, you're going to have to circle around and we'll try it again and collect it. It's just pretty much exactly like a flying science laboratory. And 5 or 6 hours can go by and you're just basically doing science. There's food, there's drink, there's a bathroom. So it's pretty fun. I have a video here of the inside. So this is just me. What I did, I held the camera on my chest and walked through the airplane. So you can see that people are up and moving around. And I'm going to Did you guys see that? Were you able to see the walk through the plane? That work? Reading through the type, yes, you saw it. And then also, if I just want to know, like, I think it's pretty cool. I'm just walking through the inside of a science plane with a camera. Do you want me to play it again? Because I can if you want me to. Just holding it for you to type. Oh, the sound went away. Can you hear me now? Hear me now? Yeah, there we go. I fixed the audio. Okay, fix the audio. So, yay, yay. So, two questions. One, did you see the walkthrough video of the airplane? And two, do you want to see it again? I'm waiting for you to type. Did you see the walkthrough video? LOL, yes. Okay, good. Do you want to see it again? Because, I mean, it's so cool. Okay, it's super cool. Okay, so I'm going to play it again. Maybe I wish I could put it on big. So I'm just walking through. This is what, it's a flying science laboratory, and you can see people are standing up. We're flying at this point. And so you can see people are just standing up working. There's all kinds of racks of instruments. And, you know, it looks like a science lab. No, it's not a 747. It's a DC-8. It's a DC-8 is the plane. It's nice. It's nice. It's really nice. I wish I had more videos to show you, but I don't know. Maybe I could try to find some for another time or send it to you. I know it's so cool. It is so cool. So this is the inside of a G3. It's just a small jet. There's only about 7 of us in there, and we're flying around the sky doing science. And the nice thing about doing this field work is that it's personal, it's connected, you get with a great team, you can go to places. It's really hard to get to Greenland. Some of the areas of Greenland, there are no roads in Greenland. Nobody believes me this. I told my husband, like, there's no roads in Greenland. He's like, what? I'm like, no, look, Wikipedia it. Greenland does not have roads. And I'll show you some photos of Greenland, and then you'll trust me. There's no roads. So if you want to go from place to study someplace like Greenland, it's really remote, you pretty much have to do it in a plane. There's no other way. So, oh, look, there's Greenland. So this is a satellite photo of Greenland, and you can see the land area is basically that white bit covered with ice, and then you can see that black around it is water, and then you can see clouds circling around Greenland. So that's where I flew with the airplane. And the reason that I flew up to Greenland is, I'm going to go back here, is, can you see that again? So I'm back on the website where you can see that red at the top. The reason we flew up to Greenland is because the planet is not warming equally everywhere. So we've added carbon dioxide to Earth's atmosphere, and it's warmed the temperature of the atmosphere, but it's warmer more near the north. And because the ice is melting in Greenland, falling into the ocean and raising the sea level, we need to know specifically how fast is the ice melting. Sea level, we need to know specifically how fast is the ice melting, so we'll know how fast the sea level is rising, because like places in Miami are flooding every time there's a high tide. And you've got problems with New Orleans and southern Manhattan and the coast of New Jersey and all kinds of places in America and all around the world that are not very high above sea level. So we want to know how fast the ice is melting. And I'll just tell you this, the ice is melting around Greenland faster than we can even measure it. I mean, we're trying as fast as we can, like, how quickly is this ice melting? And it's melting kind of more quickly than we can measure it, is like my first statement. So that's Greenland. And here's a map of where we went. And we did two things. We flew around the outside of Greenland doing kind of a lawnmower pattern everywhere where you can see like a very intricate coastline where there's a lot of glaciers. And then the other thing that we did is we went up again, and we're going to go up twice a year for 5 years. We went up again and we dropped a science probe from the bottom of the plane into the ocean. And then that science probe sent back data on the temperature of the water and the saltiness of the water. So all the dots are where we wanted to get data. And the blue dots are where we successfully collected data. So remember, science is an experiment, which means that you try your best. And as you can tell, we got a lot of data, but we're going to go back 5 times and get as much data as we want or as we can, and we're going to kind of compare the first year to the second year to the third year to the fourth year to the fifth year to see how fast that ice is melting. So those little dots around Greenland are all the places that we wanted to go and then actually did go to drop the science probes. Okay, taking a break. So here's one of the science probes, and it's about, I think you saw it, let's see here, can you see that right behind me is a kind of a crate of them? So you can see how big they are. Right over my shoulder is a crate of those science probes. And then here's one, basically, and there's a hole, literally, they built a hole in the bottom of the plane. It's about yay big, the hole. And when we get over the target, the pilot literally, there's a whole protocol. The pilot says to the engineer, I'm in position, and then the engineer opens the little hatch, and then the pilot says drop away, and the engineer says dropping, and they put this probe through the chute, and it sucks out. Everybody hears their ears pop at the same time, and then they drop, and it takes about 3 minutes to get from the sea surface all the way to the sea floor, and it's sending back data in real time along the way. So you could go and listen over your headset, and you can hear the data coming back from the probe to the engineer who's collecting it in real time on the plane, and then we circle around for the 3 minutes collecting data, and then move on to the next location. So that's that. And this is a photo I took of the plane on the runway in Greenland right before it was taking off, I think. And you can see the mountains in the background. This is the airport in Greenland. And this is a photo that I took from the plane. And this is kind of my explanation of there are no roads in Greenland because, hello, look at it. Like, there's ridiculously steep mountains. And they're covered with ice and snow, and that long, narrow blue strip is ocean water, and that's called a fjord. Now, we don't have fjords in America, but there are fjords in Greenland, and they were carved out of the land by glaciers during the last ice age. So the ice was so heavy, it actually carved its way through. So these long, skinny fingers where the ocean water comes up into the continent of Greenland, and if that ocean water is warm enough, it actually melts the ice, and the ice goes back into the ocean, causing sea level rise. So you can really see how steep it is. So the pilots had to navigate the airplane, that little NASA modified airplane, through this airspace, and it's basically uncontrolled airspace. There's no airports there. There's no other commercial craft there. The pilots are just figuring out for the first time anybody's ever been there, and they've got to fly over the water, and we drop a probe in there to measure the temperature of salinity of that water to tell how fast it's melting the ice. So that's a photo. Here's another photo. I don't know if you could see. So we're over the water in the plane. I've taken the photo out the window of the airplane, and you can see Greenland in the background. That's that land with the ice over it, and all those little white dots that you see in the water, those are icebergs floating around. So like to just see icebergs, that was the first time I'd seen an iceberg, and everybody's like, oh wow, look, there's icebergs, that's insane. So we're kind of excited to see icebergs, but at the same time it's pretty amazing, and you can see there's no one up there. I mean, it's really, the entire population of Greenland is 65,000 people, which is like nothing. I mean, there's 65,000, there's like 500,000 people in Burbank where I live. So the population is really small. There's hardly any people, a lot of ice. So we're there. Here's some more pictures outside of the plane. So you can see off in the distance is the ocean. There's a little fjord kind of in the top upper third left, and just fields of ice and ice sheet as we're flying over. And then I also took a day trip up to the edge of the glacier, and you could see that this glacier is 100,000-year-old ice, and you could see that there's a river. Oh, I should tell you, this is about 250 feet high. So this, God, how do you describe that? 250 feet is like maybe bigger than a 3 or 4 story building, is how high it is. And you can see that river in front of it, and just right in front of me, the glacier, that 100,000-year-old ice, is just melting. And you see the river, and that river goes all the way down to the fjord and out to sea. And when I was there, I kind of I knew I was going, and I imagined I'd get to the ice sheet and I'd see it melting and I'd be really sad. But what happened was I got to the ice sheet, and it was just so incredibly beautiful. I was just kind of in awe. So I wasn't sad. I was just happy to be alive on planet Earth right now. And that's the truth, even though it is melting. You can kind of see the ice is the past, 100,000 years old. That river is the future. I'm sorry, the ice is the past. The river is the present. And if you would take a video off to the right and look down, you could see it going out to the ocean, and that would be the future of sea level rise. So I kind of just felt caught in this moment in time when I was there. So this is a sign that's on the building where I work. And it says dare mighty things. And you know what, we work at NASA, and what we like to do is hard things. And I used to be a college professor, and students would always ask me, are your tests easy or hard? In a way they were like begging me to do an easy exam. And I said, you know what, my test is hard, and that's because I want you to enjoy a challenge. And I ask a lot of people, what's your favorite thing? A lot of people say sports. I love sports. I love basketball. It's really common. You can type if you like something. And I said, how would you like it if the net in basketball was really low and you had no competition and you made every shot? It'd kind of be boring, right? And the reason that we like things so much, and most of the things we enjoy, is because they're hard. And so climate change is probably the biggest challenge of our lives, my life and your life. Certainly the biggest challenge of your generation. And instead of thinking, like I showed you that photo of the bird looking at all the trash and like, oh God, this is awful, I'm not going to pay attention to it, it's too much for me, I guess what I'm asking you to do, why I put this here, I'm not asking you, I'm actually daring you. So the way I read this sign every time I walk by it is it's looking at me in the face, and this sign is saying, I dare you. I dare you to be strong. I dare you to face challenges. I dare you to run toward the challenge with excitement and passion. And so now I'm daring you. I'm daring you to stay with science. I'm daring you to face your challenges. I'm daring you to run toward your challenges as fast as you can with excitement and passion, because this is cool. I mean, challenge is what drives us. Challenge is exciting. Challenge is what moves us. Without challenge, people would be bored. I certainly would be bored, and I think you would be too. So the last kind of thing, and then I want to kind of leave it open for questions. When somebody who works at NASA tells you that grit and determination will get you everywhere, like, we literally mean everywhere. So that's pretty much what I wanted to tell you. I definitely want to leave it open for questions. I'm also going to leave this up. I know you probably do social media, so our Facebook page is NASA Climate Change. Our Twitter is NASA Climate. That's my personal Twitter. I write for a blog for the Global Climate Change website, our website I showed you before. It's climate.nasa.gov. And there's free apps. There's an app called Earth Now, and many, probably of those 20 satellites, 10 of them, you can see real-time data on your mobile phone for free. It's called Earth Now. So I'm just going to leave it there and see if anybody has any comments or questions for me, because I hope you do. Do you have posters of grit and determination? No, I made that slide specifically. I'll go back to it if you want to take a screen capture. Do you want to take a screen capture of it? You could be making money. Making money doing what? Making the slide? Making well, I mean, I'm on the clock now, so I'm being paid by my job at NASA. One of remember I told you that I think the best career advice is to have multiple skill sets. So I really like science, but I also love public speaking. Oh, you're saying I could be making money selling posters? Well, let me tell you this. Uh, Everything at NASA is free. So NASA has all kinds of downloadable posters and things, and they're all free. So NASA is a government agency, and we give everything away free to the public. So I make money, you know, I have a salary that I make, so I'm on the clock right now, but I'm not going to make money selling anything because I'm doing it for NASA. We are public servants, so we serve the public, not to make money. Like, will this be archived if we wanted to share the presentation? I think that's an answer question for Deb or for one of the people who are putting on the National Diversity Count. What is it called? National Biodiversity. But think I remember last year's. It was archived. So yes, is recording and we'll send info when loaded. Perfect. What is your favorite part? Oh, easily. My favorite part of the job is public speaking. Absolutely my favorite part of the job. If you want to know why, I'll tell you. Kind of two reasons. Let me answer. I'll answer. Okay, so my favorite part of the job is public speaking. And one reason is because I like being present and I like being connected. So I don't know if you've ever noticed this in your life, like sometimes we get caught up in our thoughts and I'm like thinking about all this stuff. But when I'm speaking, I'm totally there with you. So that's why I like it. And the other reason that I like public speaking is because I really feel like if more people liked science, then we would have a better world. And the most common thing when I'm introduced and when I meet somebody and they find out I work at NASA, the number one most common thing I hear is, "Oh, I used to love science when I was a kid." And you know, that's like, okay, great. You love it when you're a kid, but what about when you're a young adult? What about when you're an older adult? You know, we can't stop loving science. And I think that all of us have this spark, this inner science spark. And we can't just let that spark die. We have to fan that spark so that everybody, whether or not you've got a degree in science, you still understand science and you become part of scientific conversations that are happening all around us all the time, right? So we live in a world that's controlled and ruled. We use science all the time. I mean, we're all on a computer right now using technology that's based on science. There's no way to get away from it. Everything you eat, everything you wear, everything around you is touched by science all the time. So we all have to stay involved in scientific conversations that are happening around us. We have to. So that's one of the reasons why I really like public speaking. Okay, so more questions. What's the most memorable moment of my job? Wow. There's so many. I mean, just recently, more fun than Greenland. Well, I wasn't sure if I was going to get to fly on the Greenland plane. So the moment they told me you're flying, I really freaked out, and I was super, super happy. I thought that I would eventually get to fly. I had done a lot of training, so I had to do first aid, CPR, AED training, which is when you learn how to put the thing on somebody who's having a heart attack and go. So I had to learn that. I had to learn all kinds of survival training. I had to go to the Federal Aviation Administration in Oklahoma and do a 3-day survival course. I had to do hearing training. I had so many different kinds of trainings to do with Greenland. And then I had to buy steel-toed shoes because you got to wear steel-toed shoes on the plane because NASA doesn't want to get sued from somebody smashing their toe dropping an instrument, right? So I get my steel-toed shoes. And I'm all ready, but I was told, okay, maybe you'll get to fly the second flight, the third flight, the second week, sometime in the future. So I was just there to support the team, to write. I brought my really nice camera to take photos, and I'm there with the team, and the project manager says, "Come on the plane, you're flying right now." And I was like, whoa, I was just so excited. So I think for me and for many scientists, field work is really fun. So let's see, the most memorable moment. Yeah, probably field work. if you could study anywhere in the world, where would you? Well, I'm kind of obsessed with Greenland, to be honest with you. And Greenland, Antarctica. I mean, the ice. You know, when I was younger, when I was in my 20s, I traveled around the world a lot, and I went to tropical places. I went to Indonesia and China and Thailand and Sri Lanka and Costa Rica, all these places in the tropical regions where it was warm and where there were a lot of people, and I ignored the polar regions where it's cold. And I think that it really affected me, really changed me, just kind of being out there where it's so wild, so kind of untouched by humans, to just see that pristine nature. Even though it is sad that it's melting, I say it's untouched by humans, there's no footprints in the snow, even though it is being affected. I think I would go back to Greenland, or perhaps Iceland, or both again. And actually, I may be going in March, which is just a month away, so I'm setting that up. Are there other good places to study climate? Oh, well, there's many good places to study climate. So, in fact, there's other NASA expeditions. There's a NASA expedition happening looking at coral reefs, because as the carbon dioxide is in the atmosphere, it also goes into the ocean. The ocean is really good at absorbing carbon dioxide. So the ocean has changed its level of acidity. So the ocean is becoming more acidic because of carbon pollution, and that's affecting coral reefs, which is kind of sad. In fact, about a third of the coral reefs on planet Earth have died due to carbon pollution. So that's a great place to study the climate. Forests are another great place to study the climate, like in the Amazon, for example, because trees are helping. And we want to see, as we're adding more and more carbon dioxide into the atmosphere, are the trees able to grow better? Can they take up that carbon dioxide? Is there a limit to how much the trees can absorb before they stop absorbing? So we're really trying to study that as well. We're looking at snow in Canada, all kinds of things. Let's see. Other good places. Okay, are they doing any? Yes. Okay, so there's another plane called Icebridge that goes in the summer. It goes to Greenland in the Greenland summer, and then it goes to Antarctica in the Antarctic summer. So when it's summer in Greenland, it's winter in Antarctica, and when it's summer in Antarctica, it's winter in Greenland. So the plane is half and half, and we went around the coast. Remember that picture with the blue and yellow dots? We were around the coast for the airborne mission that I was on, and there's another mission that just flies a zigzag pattern over Greenland in the Greenland time of year, and over Antarctica in the Antarctic time of year, and they're measuring how much ice is being lost just by the heat of the atmosphere. So yeah, oh my gosh, would I love to go to Antarctica. That would just be mind-boggling. But yes, they are doing plane studies in Antarctica too. Okay, I don't want to get too political, but I'm curious. NASA is worried about their funding. Well, I mean, it's not actually a political question, and I can't really, I like to, how do I say this? I'm really comfortable talking about areas where I'm an expert, and I'm not an expert about politics. I'm just a person, you know, just a regular American person who has opinions, but I don't tell them in public because I'm not an expert. So NASA always is concerned about funding. I mean, these satellites, they're not free. You know, they're hugely worthwhile, right? But so we always want to make sure that the satellites and the planes are continuing to be funded. The other thing about these instruments is that it's not just like a 1 year or a 2 year thing. So when you think about funding, you think like, some of this can take a decade or even 2 decades when you think about it. So you start with scientists and engineers have to come up with the ideas first. And sometimes it's just drawings on paper, or, you know, even on a cocktail napkin, you come up with the idea. And then it could take like, you know, years to say, well, how do we make this work? We've got this instrument, you know, let's test it in a small scale, you know, and that goes back and forth, right? And then finally, when the science and the engineering is high enough where you are willing to build an instrument that you're willing to put on a rocket and send it into space, or put on an airplane and get a team to fly it around, I mean, it could take, I've known of some projects that take 15 to 20 years to get to that point where you can even start. Other projects may take 5 to 10 years. So that's way longer. We normally, and again, this isn't my area of expertise, but politics runs in a smaller cycle, Whereas the science and engineering, they're really long-term. Scientists really work together with bodies of scientists all over the world. So, so it's a much longer cycle than any one, administration. Let's see. Okay, is NASA working on solutions for climate change? We have partners. So I work with California Institute of Technology, who's working on all kinds of green fuels. So our partners are working on solutions, but also a lot of the NASA technology can be used. So for example, NASA, remember it's National Aeronautics and Space Administration. So the first A, the Aeronautics A, works on airplanes. And I was up at Glenn Research Center, which is in Ohio. It's one of the 10 NASA centers, and they are experts on working on aeronautics. And one of the things they do is they try to do fuel efficiency for airplanes and all kinds of stuff. So it's not really the idea is that climate change is a problem, so there's a solution. But there's so many things, like we're going to have to adapt. We're going to have to minimize our carbon footprint and all kinds of things. So yes, NASA is involved in all those things. NASA, certainly some of the earlier spacecraft going out into the solar system uses solar panels. So does many of the Mars rovers. And all the newer instruments use solar panels to propel the spacecraft out into space, out into Jupiter, off into Pluto, and all these places. So in order to get there, we've worked on technology for solar panels, and we're not necessarily on purpose to try to solve climate change, but if people want to use the solar panel technology here on Earth, of course. Same with things that are happening on the space station. So at the space station, they're working on water reclamation and all those types of things, and all the technologies that NASA develops can be used all over the world for all kinds of purposes, including, working on the problems of climate change. So Tom is signing out. I'm going to say thank you also. Kind of time for another question, or maybe I'll just put my, if you want to contact more, you can tweet me or Facebook me or follow our website and find out some more questions as well. God, it's so interesting. I'm giving a talk at South by Southwest, and I have to answer that question: who inspires me? I think I'm inspired by nature. I'm inspired by Martin Luther King. I'm inspired by Elizabeth Warren. I'm inspired by strong women. I'm inspired by women getting together. I'm inspired by men who help women, or anybody who's in a position of power who reaches out to people who aren't in a position of power to, give them a better life. And I guess sometimes I feel like animals, we could treat them better, because they're not as powerful as we are as humans, and like the natural world, the environment. So, there's so many endangered species right now. And it's like I'm inspired by people who connect with the environment to try to make the world a better place. And sometimes those are just my friends who aren't really famous. Where could we find good mentors for students? Mentoring high school students. There are mentorship programs. I'd have to look it up. There's a whole education area if you go to the Jet Propulsion Laboratory website where I work, there's an education button portal, and also the main NASA site. So that's where I would start looking, and I would have to do a little bit of research as far as mentors, but yeah, I think it's a good idea. I mean, to be honest with you, I'm 53, and I didn't find a mentor until I was like 50. So, I guess that's that whole thing about and she persisted, and I feel like that. Sometimes you just have to push on no matter what. And if people say no, keep going. And I mean, I'll mentor you right now. Don't give up. Don't give up. Don't ever give up. so any other comments or anything? Questions? I kind of think we're good here. So, oh, how old is your puppy? He's 3. Puppy is 3. Thank you, everyone. Thank you so much.